Oh, this problem is so hard. What's E? What's H? What's 2? I got it. Chan Academy.
Welcome to Chan's Academy. Today we will be covering 2018 AB Calculus BC FRQ number 2. I will be explaining how to approach the problem, how to solve the problem, and how the problems will be graded. Let's dive into this. Researchers on a boat are investigating plankton cells in a sea. At a depth of h meters, the density of the plankton cells in millions of cells per cubic meter is modeled by P of h, where h is between 0 and 30, and is also modeled by F of h, where h is greater than 30. Some important information to note: the units that are being used, so it's in millions of cells per cubic meter, the function that is given, and the range of this function, second function that we must solve for in later problems, and the range of that function. The first problem asks us to find p prime of 25 using correct units. So first, because this problem asks us to find p of 25, we know to use the function that is given in the problem because it's within the range from 0 to 30. Then, using our calculator, we can define a function p of h using the define button on the calculator. Then we can take the derivative of this function and immediately set this function to another value. I prefer to use two variables like p of h instead of p of h, so I can keep track of how many times it has been differentiated. Then I will plug in 25 into p of h to get an answer of negative 1.179. Then, to interpret this in context of the problem, it initially states that the units are in millions of cells per cubic meter, and because this is the derivative, we'll add an extra per meter. Now part B asks us to consider a vertical column of water in the sea with a horizontal cross-section of a constant area of 3 square meters. And then, to the nearest million, how many planting cells are in this column of water between h of 0 and h of 30 meters. So again, the range of this is 0 to 30, which is within the range of this function, so we know we're supposed to use p of h. And this question is asking us to consider a vertical column, so we can think of this as a column where the horizontal cross-section, so we can think of the cross-section like this, always has an area of 3 square meters. Because we are taking an infinite number of cross-sections, we know that we can use an integral to represent this. So we'll take an integral with the bounds from 0 to 30 because those are the bounds that we are given. And then we'll take p of h, and then because p of h always has an area of 3, we'll do the integral of 3p of h dh. And then we can plug this into our calculator. We get 1675.415. Then this asks us to find the nearest million. So actually, when we find this is 1675 million. That gives the number of planting cells in millions of the entire column. Part C states that there is a function u such that 0 is less than f of h, which is less than u of h, for all h greater than 30. And there's an integral from 30 to infinity of u of h dh, which is equal to 105. And it asks the columns of the water in part B is k meters deep, where k is greater than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. For the first part of part C, we'll write an expression involving one or more integrals that gives the number of plankton cells in millions of the entire column. And so to do so, we need to first consider the range of h. So when h is between 0 and 30, we know that we use p of h, and when h is greater than 30, we know we use f of h. And because we know that k is greater than 30, we know that we'll have to use both ranges. So we can combine these two ranges into two integrals that represent the total amount of plankton cells in the entire column. So our bounds for the first integral will be from 0 to 30, and then we'll use 3p of h, because that's representative of the area from h is between 0 and 30. And then from h is from 30 to k, we'll use a different integral, so integral from 30 to k of 3f of h dh. And this is because h is between 30 and infinity. And then for the next part, we'll need to evaluate this expression for the total amount of plankton cells. So the first part from 0 to 30, we know that we can use our answer in the previous problem in part B of 1675. And for the second integral, we know that from 30 to k, it will be less than from 30 to infinity. So we can use 30 to infinity to over-approximate for 30 to k. So we can evaluate from 30 to infinity of 3h of u of h. And then for this integral, the problem states that the integral from 30 to infinity of u of h is equal to 105. So we just multiply this integral by 3, and then we get 315. And then we can add 315 to our previous answer of 1675 to get 1,990 millions. Because we know that this number is an over-approximation, we know that the total number of plankton cells is bounded by 1,990 million plankton cells, so therefore the number of plankton cells must be less than or equal to 2,000 million plankton cells. Now we can move on to part D. So part D states that there is a boat moving on the surface of the sea, and where time is greater than 0, the position of the boat is given with x of t and y of t. And we're given x prime of t and y prime of t. And t is measured in hours, and x of t and y of t are measured in meters. And asks us to find the total distance traveled by the boat over the time interval from 0 to t to 1. So we know we can think of this as a parametric function with x of t and y of t. To find the total distance, we'll need to find the arc length, so we'll take the integral from a to b of the square root of x prime squared plus y prime squared. So that's the expression we'll be using. So we'll plug in our bounds from 0 to 1 because that's what's given in the problem. And then we'll plug in our expression for x prime of t and y prime of t. And then we can plug this into our calculator to get that the distance is 757.4558. And then we can truncate this or round this. I prefer rounding. And then so we get the total distance traveled from 0 to 1 is 757.456 meters. And because this is able to be truncated, it could also be accepted as 757.455 meters instead. And that's our final answer. Now let's take a look at how College Board would have scored this FRQ. So for part A, we can see that on the scoring board that I just pulled up, that the two parts that we need is an answer and a meaning with units. So it's very important to read the full question and remember that meaning with units is also part of your answer. So you can get your answer of negative 1.179, and then we need to interpret it inside of a sentence with the correct units. So negative 1.179 million cells per cubic meter per meter. And it's meter per meter because it's a derivative. And for part B, the two requirements are 1 point for an integrand and then 1 point for an answer. So for the integrand, we have r's right here. I'll circle it from 0 to 30, 3p of h dh, and then what's equal to, so 1675.41. And then the answer is that there is 1675 million plankton cells. So the question asks in millions, so we automatically will round to million. And then part C has 3 points, so 1 point for the integral expression, 1 point for comparing improper integrals, and 1 point for explaining. So for the first part, we gain a point by writing the expression of the integral from 0 to 30 of 3p of h dh plus the integral from 30 to k of 3f of h. So we need to know the bounds of h to get this point, and so we got that correct. And then comparing the improper integrals, we must show that we understand that u of h is an over approximation for f of h, and then we're using u of h from 30 to infinity to, again, over approximate u of h. So this can be done through inequalities or a sentence explaining your comparisons between the two, but we need to show that we're comparing the improper integrals and show that u of h is greater than f of h, and then u of h from 30 to infinity is greater than 30 to k. And then finally an explanation, so we need to explain why we get an answer that is less than 2,000 million. And then that's also answering the question again. And lastly, we can go on to part D. Part D is 2 points, and it gives 1 point for the integrand and 1 point for the total distance. So the first point is just knowing your expression for total distance when you have a parametric. So the integral of the square root of x prime of t squared and then plus y prime of t squared. And in this case, you can simply just write x prime of t and y prime of t without substituting in the expression, because it gives you x prime of t and y prime of t in the answer. So both plugging in the values in your paper and just leaving x prime of t and y prime of t would both be acceptable. And then when you get a final answer of 757.4558, and this can be rounded to 757.456, or it could be truncated to 757.455. For further practice and further review, I'd recommend going to Khan Academy and reviewing some videos about FTC, parametric functions, total distance, and deriving. And then also I'd recommend brushing up on calculator skills so that you are prepared for the AP exam. And then for further practice, I'd recommend looking up parametrics and integrals in Calculus FRQ. So you can just search up past FRQs and look through them. And yeah. And that's it for this video. I hope you enjoyed learning about the 2018 AP Calculus BC problem number 2, and see you next time.